Today we are going to go through a lot. There's a lot of details on how these things are set up, and I think there's a lot of confusion out there about how simple or how complicated it is. And you hear, sound bites from one person saying, "Oh, it's not important. You can just bolt the stuff on to the E-gear transmission," or "Oh no, you have to disassemble everything and replace all of the selector teeth." So there's a whole lot of tools and components to this setup, and we're just going to start one at a time and go through pretty much our process of setting up one of these transmissions. This should give you some insight as to why it takes us so long and why we spend so much time setting up these transmissions so that they do shift properly. So we're going to start off with the first factory tool. Now this tool is just a bracket that mounts to the shifter tower.
And the torque tube to lock it in.
Yeah, so the shifter, so a big reason why you have even a factory manual car that may not shift that well is because if you set this thing up and you either don't have the proper tools or you don't have the proper understanding of how these things get set up, then when you put it in the car, it's actually going to change, because this right here is linked all the way through this shaft and into the transmission. So this is going to go on this plate over here, and this is going to slide on there, and then as this rotates, and we'll illustrate all this in real time, but as this gets shifted and goes in and out, it's controlling this to select what gear we want. If this linkage has even the slightest change, and now this is mounted on a pivot mount, okay? This is a pivot point on here. And what's going to happen is when you slide this whole assembly into the chassis, this right here is going to be bolted to the chassis. Yep. This is also going to be bolted to the chassis by means of the engine, and the torque tube is going to attach to the diff at the front. Yep. But this mount, this tower is going to mount to the chassis, and where it mounts to the chassis, you have to orient the height based on your interior console. The height is going to be a fixed position. The like lateral and longitude adjustments are going to change depending on this position right here. These bolts can slide and it can go back and forth. Can't really go left and right that much, but there's a little bit of play in there, but back and forth is going to change it. But as you're sliding this forward, it's going to change this position, because this, again, this is fixed. So if you're adjusting the position of this, once this is mounted in the chassis, you're adjusting where the shifter center position is, okay? And you want that to stay centered. So we make two adjustments. We make the first adjustment when it's on the table, and then we make the second adjustment once we get it in the car, because sometimes it has to be, well, every time it has to be tweaked once you actually put it in the car.
And the main variable being is, this is your common point for this tool, which is one stationary point, and it's to mimic where it mounts on the body in the car for the chassis. But the issue is this positioning point can flex. So when this mounts in, if it's pushed one way or another, because again, this is bushing, if it pushes one way or the other, it's shifting this whole assembly that same direction.
Like Mark said, this tool is designed to fix this tower to the torque tube. The torque tube has threaded holes on the bottom that are going to go through these two holes on this tool, and then on the front side, it's going to mount to the holes on the shift tower, and that's going to mimic the fixed position of the chassis. But again, with these being hand-built cars, the chassis is going to be different on every one, and a little bit goes a long way. The shims are like a millimeter and a half thickness, depending on the shim, and 1 or 2 millimeters makes a huge difference in how this thing is going to shift. So once it's in the chassis, it has to be adjusted, and that's part of the problem that we're seeing on a lot of these converted cars, is that there's no adjustments once it's in the car, which that's not possible. You have to make adjustments when it's in the car to make it shift right. Yep. By blocking off every access to this adjustment system, you no longer have the ability to fine tune this once it's in the chassis, and the fine tuning makes all the difference in the world, because even just a tiny bit off and you're either gonna miss a shift or it's gonna go into the wrong gear. So you got to make sure that everything is like very precise. This a lot of precision. So let's go ahead and mount this up.
See, now it's
in a fixed position. You can't move. We can tighten this now. I left it loose so that we had a pivot, and those are 22s. I think I still got here, right here.
Got both.
Yeah.
That's better.
Okay, there we go. All right, so now we've got our fixed position. Everything's mounted up. One other thing I wanted to point out. So if you come over here and look, from the factory, if you look at any factory manual Murci, you'll notice that the shifter is sitting about right there. It's not dead center over 3 and 4. If you go to shift into third, go straight forward into third, it actually has to hop up over this corner edge. That's a design flaw that actually comes from the depth of this bottom detent hole not being the correct depth. So what's happening is it's not deep enough, and so when the detent goes in, it doesn't quite push the bottom far enough to bring it over from the right to the center. So all the shifter housings that we use are perfectly set up so that this is dead center. So you shouldn't have to start from here and then hop over this. When ours centers up naturally, it's going to be dead in the middle of 3 and 4. That way, if you just go to shift to third, this all makes a huge difference, because again, the majority of what we're focusing on is your 2 to 3 and 4 to 5 shifts, because those are your diagonal movements. This here is where you're moving diagonally, and again, this is where 2 to 3 is the most common, even though second gear reaches 100 miles an hour. So I've found myself not shifting out of third very often. 5 is pretty much useless and does the same thing as 6, which is just cruise on the interstate. So for the most part, the 2-3 is the most important shift, and you want to make sure that it can move diagonally. Now, again, we mentioned the other day in the other video that the geometry that's set up here does not correspond to this, and in a minute we're going to show you why exactly that is. We're going to show you one more factory tool before we get to that, and we're going to show you also actually 2 more tools. We'll go ahead and go through these tools, and because these are some of the setup tools. First one's pretty straightforward. So we're going to explain just the basics of what's happening in here. These are your forks. So this is going to be the first and second gear fork. This is reverse right here. You'll notice that reverse rides on a shaft and goes to the reverse selector tooth. This is the selector tooth for first gear. Okay. I'm sorry, for reverse. So first and second, third and fourth, this is your fork, this is your shaft, this is your selector tooth, and then this is fifth and sixth, your shaft and the fork. And so the forks are the same between E-gear and manual. The synchros are the same between E-gear and manual, only the teeth are different, which we explained the other day was because they have these angles in there to allow a bit of diagonal motion. Now, again, these angles are not sufficient enough because, and this is the 3-4, so this is going to be this one. They're not sufficient enough because we're tightening all the tolerances in here. We're setting this up the way that the factory should have if they hadn't designed this system in the 1960s for the Countach and then just cheated off their homework with every subsequent model. All right, now that being said, this plate that houses the shaft, where's our shaft? This shaft that runs our selector tab, this is going to fit right here. And we're not done with it yet, and I can't actually install this beforehand, but just to give you a visual. So what's going to happen here is that this is going to be attached here. And this is going to be inside that plate that gets covered on the top. And as you're shifting back and forth, it's going to be, forward is going to be kicking it out, backwards is going to be pulling it in, and left and right is going to sweep like this, okay? So that's what's happening inside the transmission when you're using your shifter right here. Now, the reason there's a problem and why the factory got the geometry wrong is that the shift that corresponds to the adjustment here. So when you're in first gear, for example, the distance of the sweep from here to here or here, any of the distance between these, which are all fixed positions, are all about the same distance, is not the correct distance that this should be moving, okay? So when you go 3 and 4, you would imagine that this would be sitting dead over the 3rd and 4th gear. There we go. The 3rd and 4th gear selector tooth, right? Well, if you have it set up so that it's dead center over 3 and 4, you won't be able to get it in reverse because it's too far out this way for it to go into 3 and 4. That becomes a major problem. Okay, so what you need to do is you need to tighten the gaps that these all have. Now, what dictates those gaps? I'm glad you asked. So there is another factory tool, which is this tool, and this tool is going to mount right here on the transmission, and it's going to have a number of accessories. This is one of them. It's going to go right here, and it's going to push these selector teeth in. And as it's pushing them in and putting that pressure on them, you're going to take these adjustment shims and drop them in right here. This adjustment shim is the gap that this should have.
And you can already see.
You can already see, even
years.
with the E-gear system and using these gaps, there is a huge variance in that thickness right there. So already you can tell this is way off for what it needs to be in order for this thing to have the correct sweep. Now, by tightening the gap between on this component, by making this so that it's tight inside there, let me get this back. So again, this gap right here, and the reason that we're tightening this gap right here is because that is slop here. So when you're in gear, say you're in gear, you can move it this much. That's this much.
Back and forth.
Back and forth. When you're in gear, in or out of gear, it's this sloppy from the factory, okay? So tightening this up, tightening everything, first of all, it's not just this, but this is one of many components that are tighter than the factory specs. Now, by tightening this, you have a limited distance that you're going to be able to move as you're going from 2 to 3 and 4 to 5. Again, because you're going from one selector tooth to the next one, that is going to try to cut it at an angle. It's going to try to catch this angle, and that's why from the factory these have these 45s cut into it so that it can create clearance for the human design, the human shifter design, in lieu of the E-gear, the roboticized version that these E-gear transmissions have in them. So because this is now tighter, which this is the only way to make this not flop around when it's in gear and make it feel precise and how it should have been from the factory, because we've widened this, now we have to take off even more on this 45. This is not sufficient. So we don't waste time installing the factory manual versions of this or replicas of them that come out of other European countries. We don't waste time with it because it's a waste of time. I would still have to take this and modify it.
because it's not to our standard.
It's not to the proper standard that this now thicker selector tab needs in order for it to have the proper motion. So not to get too far off track. So part of the last tool that we're going to discuss is a part of this adjustment is based on these all being tight and not flopping around. Now, each one of these shafts is going to have its own detent. It's a raw ball detent.
And it's similar to the cutout on this,
Yeah.
for what's sitting in here.
All right, so it's just a ball and a spring. And these, I have noticed when we take these apart that sometimes these spring lengths are different and the thicknesses are different. So they, even though they've shared the same part number for these parts since the Countach, if you go to order this for the Murci, it'll come up with a cross reference to the Diablo and the Countach. Like, again, a lot of these parts are shared. So now that this plate right here, when it's mounted on here, has these channels that are going to press down and flatten this spring. And you see how when I just did that, this can go back and forth unless there's pressure on it. Now that there's pressure and that ball is holding this on the detent slot on this shaft,
Can't go anywhere.
it can't go anywhere.
Locks your mobility in.
So that detent ball is what keeps this from moving. Now, this also provides a significant amount of feel. That's your click,
Yep.
click when you're shifting. That's coming from this ball popping out of the groove and into the next one. You can see the next one on this one when it goes is right here. When you go to shift it, it's going to go from this current slot to the one to the right. If we took all these out, you would see that they have multiple slots. Each of these is going to have 3, one for the middle, one for even and odd gear. And then since this is reverse, it only has 1, so it's not going to have 1 on the opposite side because it never goes this way. So when you're doing these adjustments with this cover off, which is necessary because there's a lot of adjusting that's going on here. When this cover is off, the factory has a tool that replicates this design right here, okay? So what we're gonna do is we're gonna mount this right here and we're gonna bolt it down, and when we do that, getting tighter. See, I'm doing the same thing I was doing, and now there's no movement. So you have to have these tools in order to do all this stuff because you need to have it properly set up when you're working on it. And without them, you couldn't possibly do a good job of this.
Accurately.
Yeah, not at all. So, okay. So now we're going to disassemble what we just did. We're going to go ahead and set up all of our setup, and we're going to show you what would happen with just installing this with the E-Gear selector teeth and not making any other adjustments or any other modifications. Because it's important to point this out, because several of the shops out there that are specializing or quote unquote specializing in conversions for these, they're trying to do them without even pulling the drivetrain out of the car. You see how deep we are in this thing to make it shift correctly? There is no possible way, no fathomable way that this could be done without pulling it out of the chassis. In fact, all of this stuff, this plate and everything is tight up against the chassis. You can't even reach your hand up in here because it's so tight against the chassis, let alone try to take any of this apart while it's in there. Just trying to do it without taking it apart makes no sense. I have a car here from a competitor right now that was sent to me to completely redo it because it shifts so poorly, and it was from the shop that insists on trying to do it the cheapest way possible. So we just got this assembled, just got our selector tab installed. Now when we put this on, there's dowels and things to line it up, but one that's really important to line up is the selector tab. And since it's just an M6 bolt,
Yep.
You don't want to go crazy torquing it down. Tight enough is, yep, tight enough. Okay. Now we've got a good sweep in here. One of the things that we're going to run into a problem with is that we figured out our reverse. This car had a reverse issue. it wouldn't go into reverse. And we figured out the reason for that is because these aren't actually aligned this direction. If I go to slide this down straight, I'm hitting the 1 and 2 selector tab. Here, it's smooth, but because it's too far, the reverse is too far this way. So from the factory, the e-gear system wasn't able to get it into reverse because it kept hitting that edge as it would try to go in, and any sort of resistance that it sees, it just stops trying.
Yep, kicks it.
So this isn't going to be a perfect example because it's not perfectly, everything's not perfectly aligned, but it's close enough that you can get the gist of what our issue is. Okay, so we currently have this set up as close to centered over third as possible, the 3/4 selector tooth. All right, so if you see in there, you've got this one's reverse, this is 1 and 2, and then the one that it's over currently is 3 and 4. So go ahead and shift 3 and 4. All right, so that's what's happening when you're going, that's 3 and that's 4, okay? Now go to 5th, I know it's gonna. All right, so that's 3 and 4. Now we got 5 and, all right, now we got, that's 5. Mm-hmm. And then we got 6. If you can see, get a little bit to the left of this with the camera, and you can see how much of that is hanging off. It's just barely touching it. The selector tab is barely touching 5th and 6th. Okay. Now go ahead and go to 1 and 2. That's 1. That's 2. And now go to reverse. And look at how it's barely on there. Get it from this angle right here. There you go.
Grabs just the edge.
See how it's just barely touching reverse? And therein lies the problem. And so what most people do is they set it up with 3 and 4 being the middle and in the middle. And what happens is you're either not going to be able to get it in reverse, or you're not going to be able to get it in 5th and 6th. And if you set it up to where you can actually get it in reverse, most of the time, you're going to have problems with it shifting into into 3rd and 4th. When you go from 4th to 5th, it's going to go right back into 3rd again. I've been talking with a guy, I won't say his name, but I am going to help him with this car. It's someone, if you're familiar with the Murci community and Murci conversions, it's someone that you would recognize. But the reason I brought it up is because it illustrates the issue that we're describing right here. So what he actually did is, to get past this issue, he actually had a custom gate plate made so that the positions were further apart to better mirror how these are set up inside the transmission. So that would be the opposite end of this mechanical function here, this mechanical action. You can either fix it right here to match this, or you can fix it right here to match this. And so again, that illustrates exactly what he did to fix his problem, because his was already in the car and there wasn't much he could do, but he was having an issue with being able to shift into 5th and 6th, and he said, man, I think that I'll get it, and then I'll go and I'll drive it, and then I'll miss shift. And the problem is that when you're driving this car really hard, which he drives his car harder than most Murci owners I know, you have to be able to rely on the fact that, hey, if I am about to do a shift from 4th at high RPMs and high speed into 5th, I need to be able to rely on it and not money shift it.
End up in 3rd.
And end up in 3rd and blow up a lot. Hopefully, if you're lucky, just the transmission, but that could easily over rev the engine and cause major catastrophic failure. So, of course, he wants to get it fixed, and we've discussed what his options are to do that. But ultimately, I'm hoping that he'll be able to look at this video, take his back apart, use the general idea of what we're doing, and get his dialed in better. And I know that's now what all my competitors are going to do too, but I'd rather you guys have cars that are set up correctly. All right, so what we're going to do now is we're going to take this back apart. We're going to make a few slight adjustments. We're not going to go ham and redo everything the way that we do just yet. but we are going to make the adjustments of these in the position that they're going to be in, their final position. And again, we'll have this taken apart
5 to 10 times.
30 times probably
Yeah,
by the time we put it back in the car. Everyone has specific things that they want with their project, and I'm only interested in taking on projects where I'm excited to deal with the owner of the vehicle and to build the car that they want. We can't convert every car. I've turned down a number of people just because it didn't seem like the right fit.
Yep.
I'm selling these kits. So if you want to just buy a kit and have somebody else install it, just make sure that it's done right. And so far, I know that nobody is doing it this way. If you want to have your conversion done the best way possible, either have us do it or follow this method. This is science. All right, we're gonna get to this. We're gonna rip this back apart. We're gonna set it up where it's supposed to be set up, and then we're gonna move on to showing you how it shifts when it's set up that way.
This is first iteration, first of the sweep of what we adjusted. You'll see how tighter the tolerances are and where it drastically changes.
Yeah. Okay, so so currently it's lined up in 3 and 4. So 3, 4, and now go to 5. Now see how 5 is, it's in the actual 5th. It's not, here we go. Yep, there you go. It's not
Fully seated.
Yep, it's seated. It's not at risk of
Barely catching.
hitting 3 and 4. And then so go to 1 and then 2, and you can see it's fully seated in 1 and 2. Now go to reverse, and it's fully seated in reverse. So now herein lies the issue. So go to 2. Now when you go to 3, you got to go over, you got to forward, over, and then 4. And the reason for that is because go kind of, all right, do it again. Just do it a few times so you can kind of get an idea. 2, 3. So imagine trying to do this quickly. It has to be a 3-part shift, a 3-motion shift. So you go, so you're in second. All right, hang on, back up here so you can see the shifter, what he's doing with the shifter. Okay, so he's in second. Now he has to go forwards, sweep it, and now go back forwards again into third. So here's your issue with the way that this is set up, is that there are diagonals cut into this so that you can move it in a diagonal, so that it has the ability to move in a diagonal. But the problem is when you try to move it into a diagonal, you're going to catch the edge of first. See how it's hitting first as he's trying to push it in? So now you need to clearance this specific corner
To match this.
To match this movement. Now what we're doing is we're cutting these 45s in, but we're actually cutting a deeper amount than what they did at the factory, and at a slightly different angle to make the clearance. This doesn't need 45s all around. In fact, yeah, this one does need some, but most of these don't need these because, again, you're only moving in 2 diagonal motions, 2 to 3 and 4 to 5. That's the only time you're ever doing a diagonal between them.
Really don't.
Yeah, so you can see it still shifts quite poorly. And this mirrors, if you watch videos from a lot of people that drive manual cars, whether it's a conversion or a factory manual car, you will notice that they have difficulty shifting because of how primitive this stuff is set up. Yep. Now, from the factory, it's much looser. Everything is looser, and so it feels wobbly. Yep. You'll notice this right here, there's no excessive play on this. Yep. There's going to be some play, but look, you can see that this is moving, and it's moving this shaft. Now we're going to disassemble this again.
Take it back apart.
Take it back apart, and we're going to make the modifications to the selector teeth that need them for the diagonal movements that we want. Okay, so we have done all of the modifications inside the transmission. We set up all of the selector teeth with the correct spacing. All right, just so you can see what we're doing. So the issue, again, is that all of these cars have a true H pattern because there's no path for them to move diagonally. And so what you see when you see videos of people driving these cars is shift forwards, over, and forwards again. Same thing in fourth. You go forwards, over, forwards, and there's a hard lockout if you try to follow the pre-cut diagonals that are in here. Now, the way that we test these is you can actually just follow the entire diagonal gate, make sure that it switches out. You can do the same thing in fifth when you're coming back. You follow this curve right here all the way and make sure that it does exactly what you want. So we have it set up through all of these. So when you're shifting from 2 to 3, it's one diagonal motion. You literally just push it one way and it automatically goes in. This is happening inside the transmission, doing exactly what we want it to do. And same thing with 4 to 5, even though this position doesn't happen very often. It's kind of hard to do when the transmission's flopping around and I'm doing it backwards. But you get the idea. Everything here is just very, very smooth. And that is the experience that PJ and others have realized that sets our conversions apart from others. Just this attention to detail. This is what you're wanting when you're doing a manual conversion, whether it's on an R8, a Gallardo, a Ferrari, whatever. When you're doing a gated manual conversion, you're expecting to get this very nice, precise shift. And not many of these cars are direct linkage. Most of them are cables. Most of the Ferraris are cables except for the 599. So really only the V12 cars have this direct shaft-driven shifter linkage, which is it's a different feeling. I mean, as much as I love the R8, I think the R8 will always be my favorite car, but this shifter feel, the mechanical feedback that you get when you shift this thing is pretty much unparalleled. So I will say that it really does stand apart from anything else that shifts like it. And again, just being able to move smoothly into all these gears can be really difficult for any one of these that's not set up correctly. Just bolting on this linkage to the E-gear setup will never work right. It's just physically not possible for it to work right. You might get lucky where you can get it into gear, you can get it into some gears, but you'll never be able to consistently get it into the gears that you want to, because the stuff that happens inside this transmission can get a little bit off, and even just a tiny bit off creates a very serious repercussion up here. When the gears aren't turning, there's a lot more play. So this amount of play can be happening, but you see this is actually moving. This is actually sliding the synchro hub, because this is the fork for this right here, the actual fork, and the fork is moving with this amount of play. Once the gears are actually turning, that hub is solid and this play can't happen. So this is the amount of play that you're going to lose when the engine is running and the car is actually moving. It makes that much of a difference when everything is rotating inside. You're going to have a lot less slop. I wish there was a way to relay just how good that feels when you're shifting it. I mean, even doing it backwards right here, it's just incredible, and it's addicting. It makes you just want to sit here and just keep playing with it like a fidget spinner or something. It's very, very, very rewarding. The feedback is very rewarding. It makes you want to go drive it and use it. So.